My name is Ryan Vanderwerf. I'm here to talk to you about clustering with Terracotta, BigMemory, Quartz, cache, kind of the round circuit of a lot of things clustering in that area. A little bit about me. I'm Chief Architect and Director of Products at ReachForce, and I do stuff, and I've been building SaaS businesses for a while. And I just published a effective Gradle implementation video series. So if you're into Gradle, you might check that out if you're in a hurry. All right, what are we going to cover? We're going to cover some clustering basics, reasons for clustering, or not to cluster, types of clustering, some session clustering abilities. I've got a few demos here, and talk about Quartz, the Grails Quartz plugin. I've got a little demo, and we've got the Grails 2 plugin, a little Quartz demo, some cache fun, and a little bit about BigMemory Max, which is their current product. All right, so this is what we don't want here. This is a beer I got from Portland. We want to avoid that at all costs, right? So it's pretty easy to get yourself in a situation with clustering where you're in some kind of nightmare and bad stuff's going to happen, or people just didn't think about it. Maybe you built an application and you're trying to scale it out, and the developers maybe didn't think, oh, what happens when multiple nodes are writing the same tables and they have caches? You know, how are they synchronized? So we want to avoid that at all possible. And one of the most common situations is, if you can avoid it, don't do it. So let me go back a little bit. So you had your traditional Grails app, and it had an cache cluster, maybe some Quartz and some clustering and things like that, and maybe it was server-side pages rendering the user experience. You had to have something like this, right? Nowadays, you've got things like AngularJS and Ember and like that, where the state's kind of kept in the client side, and you can build your Grails app to just be RESTful services, and then that way they are stateless. Well, that avoids a lot of this clustering stuff and having to do that, because, you know, best to avoid it at all costs, and the client keeps its state and the backend is stateless. That's the better scenario, but obviously you're here and maybe that's not your situation. So let's go ahead and go forward here about, do I really need to do this, and do I need to maintain state across the cluster? And if you do, then let's move on. Otherwise, you know, you don't have these kind of problems. Anyway, clustering is just maintaining state across nodes, sessions, caches, things like that. Things just working together. And we have different kinds of clustering for different kinds of purposes. And if you're stuck with a large stateful system, then you're going to need something like this. And what we mean by that is that there's many servers, applications, and data grouped together in kind of a shared brain. Gives you fast access across nodes for caching. Say someone's loaded that on one node. Instead of making a round trip to the database, it can go pull it out of the Terracotta cluster and retrieve it much faster. So I'll show you a demo of that, where it goes from, you know, almost 0 milliseconds to 3 seconds, saving that. And usually load balancers are your front line. So if you're doing a traditional data center, or you're using elastic load balancers on Amazon or things like that, that's going to help you there. And we want to do this in a performant manner. There's other ways to do this, right? And not all of them are quick or easy. Who's Terracotta? What is that? They've been around for a long, long time. They've been funding Quartz and cache development for a long, long time. Those two things are open source, with most of the features free. And there's commercial if you need multiple active mirror groups, or you want to go to the BigMemory types of stuff. They were acquired by Software AG a couple of years ago, so they've kind of went dark over the last year. No one's really heard of them. I had a frank call with them. I said, hey, what's going on, guys? I heard you're not really doing anything anymore, or you're kind of done. And they were very helpful. They got on the phone with me right away, gave me access to all the open source committers and people like that. Say, no, we're far from it. They're acquired by Software AG. Obviously, there's a change when you get gulped by a bigger company. And they assured me they're committed to open source Quartz projects and cache going forward. And they're, you know, alive and well. They also tell me they're one of the most profitable groups of Software AG, so there's no reason for them to be getting the pinch. Again, they've promised commitment to that. Where things get kind of sketchy is they haven't promised any kind of Terracotta free version at this point. I'll go into that more a little bit later. So what do we use Terracotta for? So they released their final open source version of 3.77 a little while back. And that means that that version's frozen and all new development, other than maybe some patches, are all in BigMemory. And that's their main product going forward. BigMemory Max has everything of Terracotta plus a bunch of more other stuff we'll get into later. For a while, they offered an 8 gig heap version of BigMemory for free. They took it away. I had to ask them why, and I didn't get a really good answer, but they said that they may reconsider that in the future. So right now they say, well, you can have a 90-day eval license and we will give you as many extensions as you want. Just ask. And that's their story right now. I hope they change their mind. One good project that I want to do is, because the old version is open source, I want to create a fork of that and make it work with Quartz 2.2. The problem with Terracotta 3.77 is the last Quartz version it supported was 2.1, which is not terribly old, but it's not the latest. And so obviously that's going to become a problem going into the future if you're wanting to stay current on the Quartz technology stack. So what is the Terracotta? How does it work? It's basically a TCP-based server. It's simplified networking. You've got a primary controller with a hot spare, and that controls the brain and shared state of your cluster. And they have other things called TIM modules, and they're OSGI based. You can do all kinds of other caching applications. Maybe it's for a factory or something like that. I'm going to focus more on the easy stuff that you would use in a Grails application. So what do you use primarily for? Distributed HTTP sessions. It's got adapters for most popular web containers if you're running in a traditional environment where you've got a JBoss or a WebSphere or Tomcat or whatnot. It'll plug into that with plugin code and take over the session management. And then it's also got EH cache and second level Hibernate cache support. So there's your traditional Hibernate objects that you're querying a lot, and it's going to automatically cache that state into the cluster. And we've got distributed Quartz clustering, which I do quite a bit of at ReachForce, because we can schedule loads across a bunch of servers fairly easily and it's in a scheduled manner that's not a lot of overhead. And it keeps it very simple. The BigMemory primary uses, they've added all of that and more. They've got a distributed large heap management. So basically they have a shared memory pool that's like VM memory, and you actually have to query it to know the difference, whether you're pulling memory from local heap or remote heap. And that allows for faster garbage collection, things like that. It allows a search ability across the heap. You can actually, it has a query API, sort of give you kind of a big data type of thing. The other commercial features, they have a thing called BigMemory Max, which is kind of the Terracotta cluster that you'd expect, and they have a thing called Go, and Go is just a single server remote heap extension. So if you're running a really big heap and you don't want to have your app killed by garbage collection, it can do garbage collection on its own, separate from your application, and it won't stop processing or slow down severely while it's going. It's a little more limited. It doesn't have all the Quartz stuff and all that in it. Another thing they have, hoping they release this, they hinted that they may consider taking some of the enterprise-only Quartz stuff and making it part of the core Quartz library, something called QuartzWare. And basically what it does is it gives you the ability to weigh servers and auto-discover servers. So you can say this group of servers is more powerful than this group, so this might get more jobs than this one. So you can kind of direct the flow of traffic of the jobs to specific servers with that API. Currently it's only in the commercial one, so hoping that will be free. And they have some extra security features with consoles and roles and things like that. So what the problem is, we need to evenly distribute load across many servers. These are cluster hop field here. You can see we've gone from one plant to a whole bunch of them. And there are a lot of techniques to handle this. One is a HTTP session ring. A lot of web containers have this kind of thing built in. It basically just operates in a kind of a ring pattern and replicates session data that way. So this is kind of what it would look like. And that's good, but however, what happens is cookies usually control the flow between servers in this mix here. So you have to have a load balancer that kind of sticks you on one, or have some kind of logic to do that. Otherwise, it's going to have to pull session data from the next adjacent server. And that's going to be slower if you're putting a lot of stuff in the session. So what are some other techniques you can use? You can use a load balancer with sticky source IP. It doesn't really give a balanced load, though. If you have, especially in a B2C kind of app where you've got end users, maybe they're coming from a big firewall at an ISP like, I don't know, AOL or Earthlink or something like that, and they're all pairing as or a big company. It's going to stick all those people on one server, right? So you'll wonder why this one server is overloaded and I have all these other servers sitting there doing nothing. So that's a traditional problem with that approach. You can save sessions in the database. I've seen this done before. This might be a better option than it used to be with all the NoSQL stores. Maybe you could put something in Redis or Mongo or something like that. That would actually make it less horrendous. However, if you're using the J2EE stuff, persisting that is Java serialization, which is basically inherently evil and slow. So we want to scale up. And with the Terracotta web sessions, it's really easy to set up. It's just a plugin in your web container. It gives you really good session visibility. You can use cache on its own. However, there's really no kind of console or management type of thing to see what's going on in your environment. So I've seen a situation where the IT guys didn't know cache was broken for a month, and because none of the nodes were clustered, and they didn't really have a good visibility tool to see what's going on. And the Terracotta stuff's got a pretty good web console for that. Obviously scaling, and then you've got the in-memory speed. It basically has its own proprietary NoSQL store in it that it uses. So here's your typical Terracotta cluster of servers. You got your Grails apps, very traditional application structure here, and then you've got a primary Terracotta server and then a hot spare. So these guys all share the same configuration file. So if this guy goes down here, they'll all know to go over here, and they'll become the primary. And then whenever you fix this guy, he'll go back as a passive hot spare again. And then if something happens again, they'll flip-flop between each other. So they need to be identical types of machines. So incremental changes are only sent over the wire, so it's not terribly inefficient doing it that way. You would think sending stuff over the wire would be slow, but it's actually quite speedy, especially once it's loaded in the cache. I'll go over here real quick about how to set up web sessions in Terracotta. You add a valve class to the context XML, and Webster.jboss and some of the other more traditional old school servers, you got to add a special filter as well to a web XML. Sure. Yes. So you can scale each one of these guys up to bigger boxes. I have them running right now. I've got 163 servers pointing at an M3 medium on Amazon right now, and I'm not having a problem at all. So I've got a lot more room to grow bigger. What you could do there is if you can't get a big enough hammer, then you need to go to the full enterprise version where they've got more than one spare and it can actually distribute stuff across them better. But you can get in the point where you can't buy a bigger box, right? Or if you're on Amazon, there's only, I think 256 gigs is the biggest box you can have there. So that could be potentially a problem, although it uses so little CPU on the Terracotta server, it would have to be like thousands of servers putting a lot of state through it for that to happen. Because once things are cached, it's only sending incremental stuff, so then the load on Terracotta gets pretty low. And then if it fails, what happens is, this guy goes down. These guys have logic in them. There's jars that are instrumented that are included in your Grails app. They know that they've stopped responding to this guy. They know to go try to this guy. And then once that happens, these two has an election. One guy will say, oh, I'm missing this server. They're going to have an election if they can. If they can't, then one's just going to say, I can't talk to the other server anymore. Clients are trying to connect to me now. I'm going to pretend the other server's dead, and it will be a hot spare if it ever comes back. And that's basically the scenario for failure. It's pretty resilient.
So are you saying that if the
Correct. Yeah, because there's enough logic in the client to realize that it can no longer talk to the Terracotta server. So then it's going to go ahead and go to the hot spare, because they all have the same configuration file loaded, and it has a directory of what the primary and hot spare is. So it will know that there's a problem, and it will go ahead and go to the other node. And then while that one's running, you can go figure out what happened to your other one. I've never had Terracotta just crash on me. I haven't rebooted my Terracotta server in 8 months, and that was only for maintenance. Like a lot of POJOs for cache, like domain objects, things like that, is the primary thing. And then I also use it to direct traffic for Quartz jobs. So, all right, let's jump ahead here. Yeah, if anyone has any questions, just raise your hand or blurt something out. That's fine. All right. Well, you're going to need the initial caching and loading would be slow, but then once it's cached, it's only going to send differences. So I would think that would be a scenario where you might consider having more than a bunch of smaller Terracotta servers, and maybe run the free ones in each data center. Because if you're trying to distribute a large amount of data over a slow link, you're going to have a big problem with latency. I mean, no matter what, right? Unless you're doing a bunch of caching locally on the box itself, but then you need synchronized state. I would definitely say that would be a good candidate for refactoring it to not need shared state across sites, unless you've got a fat pipe, right? If you're doing like things on Amazon and you've got multiple AZs, they've got huge pipes. I think they're like 40 gigabit or something between AZs at least. Now, multi-regions is not so good, but I don't know, if you have a traditional data center where you've got some kind of WAN link between your data centers, then you're gonna have a problem no matter what, I think, no matter what technology you're type of using. The BigMemory does. The BigMemory can actually keep its state and even take snapshots and move them around. Terracotta traditional does not yet have that. That's something they've added in BigMemory. This is just what to get it web session set up in Tomcat. It's real easy. All you do is you add this guy into your context.xml in your Tomcat, and then you're done. It'll be smart enough to figure it out. You just make sure you got the right version there, right? This is Tomcat 6, Tomcat 7 is 7.0, and so on and so forth. All right. You might have to copy the runtime jar to the lib directory. If you're using the free version, you can use Maven to resolve it, or you can copy the runtime jars into your own like Artifactory server, and it can resolve it that way, because I know Grails gets really cranky when you put stuff in the lib folder. I generally don't recommend that. It's got to be a thing of last resort. I've got a matrix here of magic versions, so depending on what version of Quartz you have, and cache, and the Terracotta server you're running, you have to have the magic 3 trinity of versions together, or the thing just blows up and doesn't work, and it will really confuse you. So the hardest part about getting that going is knowing what that is. So I've put in my slides here a nice little table that will tell you how to do that. And I'll show that in a little bit here. Here's JBoss, same kind of thing. There's just a JBoss class, so if you look at the current version of the docs, it'll give you the right one for your container. And for Jetty, WebLogic, and WebSphere, it's this filter type of approach in the WebXML. When this thing loads, it takes over all of your session management, and this is where your config file is located. Again, this config file needs to be accessible to all the nodes. I currently keep it on an S3 bucket on Amazon, because that's always pretty reliable, and then load it in memory. All right, same thing here. Put in the filter settings. This is the other half of the filter settings that you need to do if you're running Jetty, WebLogic, or WebSphere. All right. Let's break things up a little bit here. They've got a cool little demo that kind of shows you how the state works. And the way it's structured, I'll go over what we're doing here. It's running 2 Jetty servers that are going to talk to each other, and then they're going to communicate to the Terracotta server. And that way their state is shared across the nodes. So let me jump out of this. I've still got 3.7.5 on this. I've got multiple versions. All right. Restart our Terracotta server. That's the shell script that loads it, or it's got a batch file for if you're running on Windows. All right, now I'll just fire up the clients. All right, and we're going to start up our little sample server here. All right, well, let me, I will show you. I'll show you what's going on here. Seem to have a conflict here. Here's the application. It's basically a little camera store, and it just shows you the sessions. You can go ahead and shop for things, add it in, and run it. And one thing that we do get that I will show you is their cool little dev console. Let me look at this here. So here in the console, we've got the ability to see what's going on. We've got everything in our node here. We've got any clients that are connected and all the state and sessions, and we can browse, see what's going on, see what's in the heap, all of that good stuff. We can connect to multiple Terracotta clusters. So what you can do is it'll add things to the cart, it'll show it to you, and you can see their state. You've got your web sessions here. So inside of the Terracotta console that I just showed you briefly there, it'll have a listing of all of your web sessions across your cluster. So if you notice something nefarious going on, you can actually start killing their sessions on them while they're using the site and reset their state if you want, or you just want to know how many sessions are going on in the cluster right now. You can go in there and use that tool to see what's happening. You can enable statistics and gather all kinds of things. You can even browse through the contents of the session. So if you're shoving objects in there and they have any kind of visualization of strings that you can see, and you're not shoving Java objects in, you can actually browse through and see what's going on, which is kind of neat. So if you see something's wrong, it's a good debugging tool if you're having session problems. Here you can tell you some statistics, how many sessions are created per second, how many are hopped between nodes. Say you're run robining or something, and it needs to go pull that state again from Terracotta. It'll tell you that, and tells you how many active sessions are going on right there. So you can get some performance metrics about what's happening in the system. And here's where you browse the runtime session data. So you can go through here. Here's the session going, and I can see that's the session ID, and that's what's going on. So pretty neat. All right, let's jump into the application database caching. So why would I need this? Take a load off the database. That's the biggest one. A lot of people don't think about that, and the application is performing very poorly. We need to increase the performance. We need to ease the scalability. This happened over and over again where the developers didn't see or think about this, and they didn't even think to put the system in. And they said, okay, we're ready to go live. And like, what is the cache? What cache are you using? EH cache. Well, how they talk to each other? Oh, I don't know. That wasn't, I didn't think about that. How are these caches going to talk together? You need something like this to synchronize all your caches, or your database is going to get stomped on. Hopefully you've done at least optimistic locking so you can have a last chance thing on it. So what are the other options for application and database caching? You've got EH cache. You can do that straight. JBoss cache, JGroups, and roll your own. I've seen some people do that. Or Hazelcast is a really popular one that's open source. I'd definitely take a look at that. And then you've got Terracotta and the BigMemory thing. That's kind of it's a big hammer for that problem. So EH cache, it's fine on its own. I know a lot of people use it, but it's hard to debug. It's hard to figure out what's going on when it's not working right. If you're on Amazon, you've got to, you can't do multicast, so that's, part of that's not going to work. And it really uses JGroups under the cover. But it can cause odd network issues, nodes kicking each other off. When you got no multicast, it's a lot more difficult to set up. And you've got no real console to see what's going on. You could try to find some tools to do that. But it's pretty ad hoc kind of stuff. JBoss cache is fine on its own. I'm not sure how many people use it these days, but the Grails plugin is really old. So I wouldn't trust that personally. It might work fine, but it was only tested on Grails 1.1, and that's really, it's eons in our time, right? And again, it uses JGroups under the cover anyway, so. I've heard of people having multicast issues on cloud providers with it. And again, it doesn't really have a really robust console either. You can roll your own JGroups. It's really hard to manage. It's pretty difficult. All the cache responsibilities are on yourself or on your dev team. So why would you do that when there's all these frameworks to do it for you? Again, no visibility, and it's complicated. Hazelcast, this is a really popular option. I would definitely look into these people if you're looking at doing clustering. They were is created by one of the former founders of Terracotta. They broke off at some point and formed Hazelcast. Hazelcast has basically been eating their lunch for a while because they've been gobbled up by another company and moving a lot slower. They're all open source and free, and you get paid support, so it's a really, really great option. The Grails plugin seems to be a little out of date, though, so I have not tried it. I don't know how well it works. It would be worth fixing up the plugin if it does. And it supports most kinds of things Terracotta does. It does not have Quartz ability, though, and that's kind of a little bit frustrating. They made their own version of an execution engine scheduler thing, but it's called something else, and it's not compatible with the same Quartz libraries that you might be used to. So you'd have to redo all your jobs into that framework to make it work, although I bet it works pretty well. So the Terracotta EH cache stuff's great. It integrates into a console. It's got a centralized server. It's less complex. It definitely works in Grails too. I've got a Grails app here it's running in. And it's really fast because it only transmits deltas of things that have changed. The open source version, which is what I've been showing here, that's free for most installations. It's good enough for where I'm at. You can always just add more clusters. If you can break things into sort of a microservice type of thing and you still have some state, you can split things apart that way. It's got a great developer console, tells you what's going on, full insight to the cache. It's got an express install. It's really easy to set up. Okay, here's the magic table. So if you want to use this stuff, these are the magic version numbers you need of all these things, depending on what version of Terracotta you have, what version of Quartz you're running, or what version of cache you want to use. I've got an example out on my GitHub page that's got all these working as an example. This is the hardest part of getting this stuff working, is you need to know what these magic version numbers are for the dependencies. If they don't match up, it won't work. So there it is. You can use that in your slides if you want to consider it and pick the right one for your situation, and it'll be a lot easier. So what do we need to do to set up our Grails on it? We got to modify our build config, make sure versions of cache core match the Terracotta install. They have specially instrumented versions of cache that you need, and they have to be compatible with what's in Grails. So you may have to exclude some libraries out of Grails. And make sure there's a Terracotta toolkit jar. That's what it uses to talk to the server. That make sure that matches. And then there's the cache Terracotta additional jar. Make sure that matches as well. So here's what it looks like. Here's an example of, this is the latest version of 3.7.7 of Terracotta open source. So basically, if you just plop that in your build config.groovy, you're good to go. All these things are resolvable from the public Maven servers. So, all right, and I've got another color cache demo. It's the same type of thing here. What it is shows the example of caching. So one node can load something, and you can type in a color, for example, and it'll go ahead and like pull that, and it may take 3 seconds. See here, color red took 3.6 seconds. It's not in the cache yet, right? So I can go to the other node, the adjacent one, and fire that up, and it'll tell me what colors are cached. So if I pick one that's already cached, it'll load up, and it'd be 7 milliseconds or less. So the difference, it can be pretty huge, and that's just colors. I mean, think if it's something real, it's, you know, state you have to deal with. And once you fire up the color cache thing here, this is the console that I just showed you briefly. It shows you all your caches, what the values are, what your hit to miss ratio is. So basically measures the efficacy of your caching. So here's an example of one where I'm getting no hits, right? I just fired it up, and nothing's really going on yet. You can expire items in the cache. You can set how long they live. So if you want to force things after an hour to always flush no matter what, you can do that. All right, let's jump into Quartz. I find this is a little more interesting. We use this quite a bit at ReachForce. Obviously, what is Quartz is, how many people here have used Quartz before? So it's pretty much the de facto scheduler kind of thing, right? It's been that way for a long time. Again, why would you write your own if you have something like this, right? That's kind of crazy. I actually ran into that before. So people making their own schedulers that aren't as good just because they can. I don't know. It's got great Java Grails support. It's supported by Pivotal. I try to help out with that plugin too, and Graham Roche's done some improvements on it lately. It's by far the most supported type of thing there for Grails. And the most common solution is for executing Java applications on some sort of scheduled manner. And the development for Quartz is funded by the Terracotta AG now, because they're an independent subsidiary of Software AG. They're committed to funding the support going forward for Quartz and cache, so it's definitely not going anywhere. The Grails Quartz plugin integrates with Quartz 2.2. If you want to use Quartz 2.2, you're going to need to run its own clustered mode, backed by a data source like a database. This one's officially supported by Pivotal. You can use the latest plugin version for if you're using a data store to back it up. If you're using Terracotta, you got to use RC7. That's the last one that supported Quartz 2.1. You can Try to run the newer versions and exclude the jars. That may or may not work for you. Sometimes Grails doesn't like you to mess with the EH cache versions. For BigMemory, you can use Quartz 2.2. So maybe if they decide to make a free version of that, you could be current, and that would be that. There was a Quartz 2 plugin. This one's not maintained really anymore, so I'm really putting this up here to show you what you probably shouldn't use, is this one. They've kind of been abandoned at this point. The efforts to integrate those two plugins together is an ongoing effort because they did support some cool stuff. You can still use it with a JDBC store backing of it, but it does have a pretty slick, groovy DSL for job details. But it's not officially supported by SpringSource, and it hasn't been updated for a couple of years now, so I would skip that one. So why do you want to cluster Quartz? Why not just use the JDBC store database? For one, you may want to distribute the load. You want to scale easily, and you want to handle a bunch of batch jobs at once. We do lots of jobs in our microservices actually for Quartz where maybe it's just some repetitive task that happens over and over again, and maybe we scrape some information out of our system and do some kind of discrete function. It works really good for things like that, and it's simple, right? You can do a Hadoop cluster and you can do all that, but that's a lot more heavyweight kind of solution. This is very light. You can make Grails apps that just are process jobs, and that's all they do. And that's what we have, like a whole group of nodes that do just that, run Quartz jobs. If the system crashes, you can persist the work queue, which is nice. So say some servers go down and they don't process the jobs all the way, it'll still be persisted in the queue and you can resume them without really any loss of data. And you've got really good failover, right? So you have a bunch of servers running Quartz stuff. You can lose a few nodes, and it definitely happens in the cloud quite a bit. On Amazon East is where we're at, and quite often servers die and fall over, and you have to be really a tool like this to help you with that. So how do you install Quartz and create a job? There's one way called dynamic jobs. Here's an example. You basically just create a job is what it creates when you install the plugin. It'll have a little jobs directory in your Grails app, and you just add job on the end of it, and you can get parameters out of there, and that's how data is passed into your job, is this map, and then you can trigger it right now. So a dynamic job means I've just created a job and I want it to happen at some other time, and it may run on some other server. I can trigger it immediately, and that's one way to fire up the job. You can add the plugin to build.groovy, and it even has a little script here. You can say create job, and it'll create the jobs for you. You just give it a name, and it'll start out with this default thing here where it says it's simple trigger. It's just got a delay of whatever you want to set, and the repeat interval. The delay is important because if you boot your Grails app up, you don't want all this stuff to fire off at once before the cache is warm and the system's at its slowest point. So you may want to wait a minute or two before you start processing jobs just so the rest of your application stand up properly. And you can define groups there as well. If you want to have different groups of stuff and you want it to run on different groups of servers, you actually need to set the scheduler name in the Quartz config. And that will allow basically you to have concurrent different batches of jobs going on. So here's a cron trigger example. You can give it a cron. This is just a warning here. This isn't full cron. You have to check their reference. You can't do some things that cron can do. They have their own sort of version of cron, so you definitely need to check the reference docs before you want to go crazy with cron stuff. Still, it's pretty nice and it's pretty handy. So how do you make another dynamic job here? Here's the code. You just say schedule it. You can give it a cron expression if you want, and this will create a job that repeats one time with, there's the parameters here. That's all you need to do. And it'll go about its business. Here's the rest of the code for that here. And you can say trigger now. Do that. You can make a custom trigger class, do some maybe something that cron or immediate or repeating interval isn't good enough. You've got some other kind of logic that's pretty complex. You can make it your own if you want. So how do you prep your environments? You have to know where you want to run the jobs. You can replicate a Grails app X number of times and distribute across that. You can have a separate replicated application for that. One trick that we do is our web UI starts up and has a thread count in Quartz of 0. So that means it will never try to actually execute any jobs. It just schedules the jobs. And then on the other nodes, we have a Grails app that's basically just processing jobs, and it will have a thread count set that's not 0, and then those are the ones that actually run the jobs. And that way the web front end's never bogged down by running these things. So you can run your own standard application. You can have Java classes running command line. I've seen that done before, where you just use the Quartz API and it's just a standalone app. It's not a web app. I tend to make everything kind of a web app anyway these days, just so I can have remote monitoring on it and keep tabs with its health. You can use a standalone plugin and make it into an app with Grails, so you don't need to distribute it to a web container. This plugin here works pretty good. I know some people have said they're using that in production. So what's the difference? You can use Terracotta or the JDBC job store clustering are the two main options. There is a Redis job store as well you can use. However, it doesn't support multiple scheduler names. So if you've got multiple applications sharing the same context, you may need a Redis server for each application. But it's still, if you use the Terracotta, you've got a nice GUI console. You can see what's going on. You don't really have that with the Quartz stuff. You can make your own app to try to do it. There's even a Quartz monitoring plugin for Grails. I think its status is fairly old. I haven't tried it recently to see if it works. I'm sure it's broken with 2.4 version of Grails. And Terracotta was cool about it. It uses its own sort of internal NoSQL database that it takes care of on its own, so you don't need to do all that stuff. Just another database to manage and maintain is a pain versus using the JDBC store. And you can use the free version of Terracotta, and it's good for quite a bit of stuff. Both solutions, if you're going to implement this, make sure that you have a time server synchronizing the clocks and the machines. If the clock gets too far off, Terracotta will think something's wrong, and then it'll start what they call shunning nodes. It'll say, you're trying to talk to me, but you say it's, time is way off, like 15 minutes plus. It'll not let it talk because it thinks maybe something sketchy is going on. So you got to make sure you do that. And apparently the requirement, if you're using the JDBC store for clustering these jobs, is that it needs to be within 1 second of the server, or you get odd behaviors where multiple servers could be trying to execute jobs at once, or missed jobs firing and things like that. So it's definitely more sensitive if you're using a JDBC store instead of Terracotta to cluster your Quartz. So this is the most common thing people use the Quartz, though. It does work well. You got the time server thing handled. You can see some state in the database, so you can kind of look in there and see what's going on, but it's not as robust as Terracotta's toolkit APIs. And this works with either of those Quartz plugins. Terracotta, you don't need a database. It works with all the latest Quartz, Quartz 2.1, I should say. That's kind of a misnomer there. The reason why the Quartz 2 plugin doesn't work was because of this bug here in Terracotta. It's actually a Quartz bug, but get more details about that. We got the slick GUI, we got excellent failover and hot spare. You've got your second level cache and your session management, and you can have your Quartz stuff. It's kind of a one-stop shop. It's definitely a good up to medium installs. If you're really, really big and you're running thousands of nodes, you definitely need the commercial version. So here's how we get Terracotta set up. Just download the 3.77 open source version. I've got the link at the end of the slides here. Again, install your Quartz plugin, set up your Quartz properties. Got an example file even for you. Here's what your Quartz property will look like. You make sure you use this Terracotta job store, and where to find your configuration file. Configuration file can be in an S3 bucket, it can be on a web server, it can be on some kind of shared file store. It doesn't really matter as long as you can get to it. That's fine. You have an instance ID. This is the name of the node. You can also specify this scheduler name here, and this is what would separate multiple applications running. So they don't, say you've got one group of servers made for picking up a certain kind of job and a different set of servers for a different kind of job. You got to make sure that you've got unique names here so they're being processed on the correct node, because you don't want to have to set up multiple Terracotta servers for nothing. So there's the link to download it. Set your Terracotta home variable. Set up your Terracotta config. You can start with the basic one. Fire it up, and then you run your developer console. The JDBC job store is also easy to set up. You can let it do auto node IDs. I would recommend doing that, because if they're not unique, it will cause confusing things to happen. And again, there's the warning about your time server. So here's an example Quartz config file, pretty simple. You just need to tell it also the right class name. So in this case, it's using Oracle. If you're using MySQL or whatnot, it has to be a SQL-based store to use this job store class. If you want to use Redis, there's a Redis job store class specifically for that. Yeah?
I have a question. So the difference between the job store TX and the CMT,
Oh, the
Grails, it talks about whether you're going to manage your transactions or Quartz is going to manage your transactions.
yeah, so you can.
I understand which one I should use with Grails.
This one works. I've used it before. I use CMT sometimes if you're going to use it, give it like a JNDI URL, and maybe your Tomcat's managing your database pool for you. We actually run some apps like that, just because that means all things come from their own pool of connections. If you let Quartz, in this case, run its own pool, then it's going to have a separate pool of database connections in addition to what Grails is using. So now you've like potentially doubled the number of connections to your database server without even realizing it. So if you use the container managed one and use a JNDI URL, whenever it needs a connection, it caches the JNDI lookup from your web container, like Tomcats works pretty well. Then you've got one set of pooled connections across your whole application, and you're not doing multiple pools. You can definitely run a connection limits there.
So in that case, I should use CMT.
Yeah, if you're using Tomcat or whatever's database management, you should do that. And then in Grails, you do the same thing. So in your config Groovy, you set your database connection information to use the JNDI URLs, and then you're good to go. You can do some other stuff here. Here's the rest of the config file example here. Tells you what to do. So what can you do with this stuff? You can do some pretty neat things. You can use job and listener triggers. There's no Groovy version of that. You just have to leverage their Java API in your Grails app. However, you have to be warned that these listeners don't work across nodes. So that kind of hampers it. What we've done in some cases is taken the states of jobs for that moment and put them into a Mongo database. And that's where states pulled in between things, because there's like this gap of functionality where trigger listeners don't work across nodes. I believe the BigMemory version fixes that, but you're going to have that problem. That one burned us once before. You can make one master job that fires off a bunch of little jobs, and then all your nodes can run those. So it's kind of a little cluster bomb type of pattern. That works really well. What could you do with it? Make an email campaign tool, for example. You're sending out tons of emails, legitimately, of course, right? You can do a bunch of data processing. Maybe the Hadoop stuff's a little too heavy for you. You can do some pretty powerful stuff with that, running it across a whole bunch of worker nodes. Email verification tools, one thing that we use it for at ReachForce. So you can verify a list of emails that they're still valid. So we have a whole bunch of proprietary funness that tries to figure out if an email is valid or not without actually emailing the person. Those are all kinds of cool things you can do with it. I'm going to skip over the Quartz 2 plugin stuff in the interest of time, and plus we don't want to use that one anymore. It's basically deprecated. All right, BigMemory Max. So this is their product going forward. I'm hoping they will make a free version again. It gives you everything that we talked about with the Terracotta, but we've got a distributed large heap management for really high availability. And that allows you to do things with the heap, like take snapshots of it and restore it if you want, and move them around. You can get around JVM heap limits, right? So now it kind of acts as an extension to your VM's allocated memory. So again, the performance benefits of doing something like that, where garbage collecting is running in parallel while your application is running, is very powerful because, as we know, garbage collecting on a single app kills performance. It always gets a little bit better every revision of the JDK, but it's never what it should be. You can also use an in-memory data store with it, with search. They have their own little search API, so you can use it kind of like a distributed data store. Basically be like a Redis or something like that, except for it's kind of all bundled in here. It's got main feature parity with the old Terracotta at this point. So for a while it didn't have Quartz support and these other things. So here's a typically memory layout, the way BigMemory works. So right now, without BigMemory, you've got a heap and some unused memory. You can shrink down your VMs on the individual machines to be a smaller amount of what it needs to boot, and then your BigMemory machines got all the RAM in that shared state. So you can also do a typical scenario is like this, where you've got multiple nodes going on with app servers, and you've got a Terracotta server array here where you can have main, spare, and then a bunch of other BigMemory nodes. And this would be the situation where you're running like the thousands of nodes and you need that state going across. But I don't know if you're trying to spread that state across sites, how well that would function. It's definitely something I haven't tested yet. So here's what the way the heap works. So you've got this sort of heap store of everything, and it gradually goes off even to disk or an external data source. So depending on how much data you have and how much speed you need, basically you scale up your BigMemory boxes and heap in those machines to give you the speed you're looking for. It's good to know what those requirements are. Go does the same thing, BigMemory Go, but it's only on a single machine. It's not a clustered hive brain. So here's a chart if you want to use BigMemory Max. I've got that working in a demo Grails app on my GitHub page. So if you want to try it out, you can just go to their website and get a 90-day key anyway. And these are the versions of the libraries you need to make it work with the current Grails. I tested this with Grails 2.3.9 and it's working, so I haven't tried 2.4 yet. Again, these magic things are what you probably waste most of your time trying to do to figure this stuff out. So I've already done the work for you. All right. All right, let's fire up BigMemory here real quick. I have a little Grails app, and you can see some neat things about it. BigMemory. And this is what I'm about to show you here is BigMemory Max. So all right, fire it up here. I've got our server running. I had to boot this back up again. I rebooted my machine a couple of times. All right. Okay, so again, I've got this app is posted out on my GitHub page, so here's the build config Groovy you need to make it work. It's got all the dependencies set up as a kind of a shell app along with the right jar files. You can't access the Quartz enterprise stuff via Maven, so you're going to have to either put those in your own Artifactory server or you're going to have to put them in the Grails lib directory, which always makes my skin crawl a little bit when you have to do that. Shrink this down. All right, so we're talking to our server. Grails app started. And I put together a little page here that uses their own API. So this uses the Toolkit API. So now I can tell me these are the current client node that I'm on. These are the nodes in the cluster. What their host names are, what their ID is, and what name Terracotta is assigned to them. You can also programmatically set your own. And then it also tells you what about the topology of the network, what channel the thing's talking on for each client, and is your state of the cluster running or not running. So you can get all of this stuff through a little API. I've got an example page you can pull down off my GitHub page and inspect kind of the cluster and see what's going on there. Not everything is available in the Toolkit API. For example, let's show you. Some things you can only get access via JMX beans. Here's the controller class here with the code in it. And this is basically all I did was you get a cluster info object and do that. If you have Quartz running, it doesn't give you the status of those from this Toolkit API, but they do expose JMX beans. On BigMemory, they actually have a REST API. You can query the state of things also, in addition to this traditional Java native API. This will work on the free version, Terracotta 3.7.7. This Toolkit API works as well. And you can use JMX beans. That's what we use. So you can use a combination of inspecting JMX beans from Terracotta when you connect to it. It's got a JMX port it listens on, and a combination of that and this Toolkit API, and you can really know what's going on in your cluster, so your application maybe can react appropriately to what's happening. And one last thing here, show you the cool little console they've got. It's web-based instead of a Swing app. This is our management console. And so here, this is the web-based one, which is easier to deal with because you don't need a fat client installed. It gives you all the same information about your cache statistics, how things are going. If you're running Quartz, it'll pop up an extra tab there, and all the nodes you have in your cluster. So you can go around and walk and figure out. And this one also does interesting things like on a node, you can take snapshots of the memory. Maybe you need to find out later, do some analysis on what's going on. You can take a snapshot of that and export it out and then grab it and go through it and see what kind of nefarious things are going on in your network. All right. That's all I've got. Does anyone have any questions? Yes? Yeah, so Terracotta are the people that fund EH Cache development. So you might see the company name in there. But EH Cache is totally free, and they're going to continue to develop that. Apparently, they've got a new version coming in a few months that's going to have a lot of cool new features to it. And they've committed to saying that's going to stay free and open source for sure, and along with Quartz. And they may even give more functionality to Quartz. The thing that's kind of up in the air at this point is whether or not we'll get a free version of the BigMemory Max. That's because to have those advanced functionalities, you got to have that version, and it gets pretty pricey. So I don't have any quotes on prices to give you, but you'd have to ask them. I run all the free open source stuff personally. So if something doesn't happen eventually, I'm going to fork off and build my own version that's got Quartz 2.2 support in it. But I don't know how easy that would be. It might be really, really hard. But yeah, that's it. All right, thank you.